Sometimes when you're solving an equation, the variables cancel out. So one case we can have with this is what's called an identity. An identity is an equation that is true for every possible value of the variable. In other words, any value of the variable would work. So for example, if I have an equation x plus 1 equals x plus 1, any number I put in place of the x would make this work. Sometimes it might not be as obvious as this. Sometimes both sides of the equations are not identical to begin with. They might get there towards the end of the problem. And if you don't see it, just follow your normal steps. So our normal step would be trying to get the variable on one side. So we could say let's subtract x on both sides. Now what happens when we do this is it's actually going to cancel on the left side and the right side of the equation. So what we're left with is 1 equals 1. So if the variable cancels, we're just going to decide whether we have a true statement or a false statement. So we're just going to think about, does 1 equal 1? And the answer is yes. So this is a true statement, which means we have an identity. Okay, in other words, x could be equal to 0, x could be equal to 5, x could be equal to negative 1 million. Any number we put in for x is going to make this equation work. One way to help you remember this word identity, or that you have an identity, is if you look at some point, again, maybe not at the beginning, but at some point towards the end of solving the equation, you're going to end up with both sides of your equation are identical. So identical identity might help you remember that. Our other case is what's called no solution. No solution means no value of the variable will make the equation work. There's nothing we could put in place of x that would make this work. So for example, if we have an equation, we work it out maybe to a point, and we get to 3x minus 2 equals 3x plus 4. Again, our next step would be to get the variable on one side. Once again, if I subtract 3x on both sides of the equation, those will cancel on both sides. So we'll be left with negative 2 equals 4. Negative 2 is not equal to 4, and so that means we have no solution. Sometimes instead of writing no solution, you might see what looks like a 0 and a line through it. And that's another way of saying no solution. So if we look at this problem, the first thing we're going to want to do is on the left side we have parentheses here we can distribute. So we distribute that, we'll be doing 3 times 4b would be 12b. Minus 3 times 2 is 6. Once we do that, we're actually at a point where we could make a determination here. A lot of times you may not see it depending how the problem is. This one's in disguise a little bit. So what you might do is just autopilot, keep working the problem. Getting the variable on one side, you could subtract 12b on both sides of the equation. And when you do that, watch your signs here. We'll end up with negative 6 equals negative 6. Negative 6 equals negative 6 is an identity. If they ask you, like this problem does, to tell what the solution is, if they say what is the solution, Identity isn't a solution. It's not telling what the solution is. If it asks what is the solution, then you will just say infinitely many solutions. Okay, and again, it's still meaning that anything will work. It's just kind of a matter of saying that infinitely many solutions versus identity based on what the question is they're asking us. This problem, similar story. This time on the left side of the equation, we would want to distribute. So in the parentheses there, if you want to add the opposite, you can. If you don't add the opposite, I would suggest circling that so it looks like a negative 2x. So the left side's going to stay the same. The right side we distribute. Negative 3 times 1 is negative 3. Negative 1 times negative 2x. Negative times negative would make that a positive 2x. Again, at this point you might notice the variable terms are identical to each other on both sides. So if you want to make your call there, you can. If not, be a little bit more obvious. Subtract 2x on both sides. We get 7 equals negative 3, which we know is not true. And so we could say this equation has no solution. So if it doesn't work, it's got no solutions. If it works, then it's infinitely many solutions. And again, if you wanted to just do this, means no solution also. So this problem, again, we're going to want to distribute first. So half of 6 would be 3. Half of 4a would be 2a. If you notice, these are being added together. So commutative property says addition can be rearranged. So if you wanted to do that, you could. Otherwise, again, getting rid of that variable makes it really clear to see. 3 equals 3. And this says to solve the equation. So I guess we'll just go ahead and say infinitely many solutions again. And as far as any abbreviations, I guess if you want to do INF period for infinitely, it's really not that bad to just write it out otherwise, but we don't have just a symbol like the no solution for that. This problem, very similar. We're just going to distribute first. So 2 times 2x is 4x, 2 times 1 is 2. And again, you might notice here variables are the same, constants are different. If you don't see it or just want to clarify things here, subtract 4x on both sides, you got negative 5 equals 2, and that means no solution. And again, these are going to be mixed in with other problems, so when they're mixed in, you kind of get on autopilot a little bit more, and you're not just strictly knowing that you're going to have one of these two cases. So autopilot might get you to a point where you get to that negative 5 equals 2 step, and that's fine. Again, it's really clear when you get to that stage. It's sometimes more clear than not subtracting the variables first. So this gives you an idea of how to work with problems that have no solution or infinitely many solutions.